So let us discuss how we perform the transformations. So to do that, we let us consider our axis system. So if as we were discussing here, if this x4 y4 z4 coordinate system is our body fixed coordinate system, and this is our earth fixed coordinate system. So we want to transform these the vectors in the earth fixed coordinate system to the body fixed coordinate system, or the other way around. So let us start with the coordinate system in the earth fixed coordinate reference axis. That let us put it in this way, that okay, so this is x1, this is y1, and now the z1 axis is into the sheet, into the paper. So this is the origin, and if we take any rotation, suppose I took this way, okay, I took this way, so this is the final position after the rotation about the z-axis. The rotation about the z-axis is also known as psi. It will give us the psi angle, yaw angle, right? So the final position is suppose x2, and this is y2. So how can we write x2 y2 in terms of x1 and y1? To do so, we can write the algebraic equations, that is x2 equal to x1 cos psi plus y1 sin psi. Similarly, y2 equal to minus x1 sin psi plus y1 cos psi. z2 equal to z1, because the rotation was about z1, so there is no component of x1 and y1 in the z2 axis. So now these equations can be represented in the matrix form, and it can be written as x2 y2 z2, then cos psi sin psi minus sin psi cos psi 0 0 0 1. So why do we need matrix form? We could have done the algebra in this form itself. Well, the answer to it is as the equation evolves, when the more rotations are involved in the process, these equations become very hectic to deal with. So this matrix representation gives us a more compact formulation, and we will see how we can do that. First of all, to avoid these again and again writing this cos sin term, we can write this matrix as C psi and S psi 0 minus S psi C psi 0 0 0 1. So this is more compact than this one, right? However, our aim is to see how with minimum number of variables, how can we represent this? So we can write this equation as x2 equal to c x1. So basically this vector is x2, this vector is x1, and this matrix, which is a 3 cross 3 matrix, is C. Okay, so this is very compact compared to this one, right? Now we will proceed with the next rotation, and that is about the theta axis. So let me draw it. So this is x2 and this is z2, this is O, and y2 axis is into the paper. Now we will rotate it in the similar fashion. Okay, so now this is theta, and this is also theta. This is x3, this is z3, right? So now similar equations can be written, and x3 and z3 can be written in this fashion: x3 y3 z3 is equal to c theta 0 minus s theta 0 1 0, s theta 0 c theta. Fine, very simple. There is no complex mathematics involved here. It is very easy. And then this boils down to x3 equal to b x2. So this is x3, this is b, and this is x2. Okay, so we are left with the last rotation, that is about the roll axis, that is phi. So again we should take in the same similar fashion. So this is the origin, and this is y3, this is z3. Now this is the origin. So x-axis now is into the paper. So you see, this is y4. We are rotating the axis system about the x-axis. So this is z4, and this is phi. This is also phi. So now you might be clear about the concept that why did I take initially x4, y4 and z4 to show these two intermittent steps. Okay, so again similarly we can write x4, y4 and z4 as 1 0 0 0 c phi s phi and 0 minus s phi c phi. right? Then x3, y3, z3, right? So again this can be boiled down to x4 equal to a x3, where this is x4, this is a matrix, 3 cross 3 matrix, this is a vector x3. Okay, now x3, you see this x3 can be written as b x2 and x2 can be written as c x1. So this term can be written as x4 equal to a into b into c. So these are 3 cross 3 matrices each. They have been multiplied, matrix multiplication with x1, right? So while after multiplying these three matrix, after performing the matrix multiplication, we will get an expression like this: x4 equal to t1 to 4 x1. Okay, so what does this mean? It means that okay, now you see any vector in x1, which is the earth fixed coordinate system, can be represented in body fixed coordinate system with a suitable transformation. So you suppose you have one velocity vector with respect to your earth fixed coordinate system, and you want to see how does it look like in the body frame reference system, then it should be this expression should be performed. Similarly, as we had earlier discussed, if we want our body fixed coordinates, a vector in the body fixed coordinate system to be seen in the earth fixed coordinate system, then this expression becomes t1 4 inverse x4, right? This expression. So I have already made it. Written the transformation matrix. So this is how it looks like. So this t14 looks like this. Okay, after the multiplication of all these 3 cross 3 matrices. So this matrix is also 3 cross 3. Okay, and okay, so one more thing to be noted here is that these transformation matrices, like this is a matrix, and similarly this is B matrix and C matrix. All these matrices are orthogonal matrices. So therefore their product ABC is also an orthogonal matrix. Because they are orthogonal matrices, the product is also orthogonal. So by using the property of orthogonal matrices, we can write that this matrix, by taking the inverse of this matrix, will give us this matrix. This matrix, which says that, what does this say? This says that this matrix transform any vector from coordinate 1 to 4. So the inverse of it would be the transformation matrix of any vector from coordinate system 4 to 1, and using orthogonality it would be just the transpose of it. So you see this matrix and this matrix, it is just the transpose of it, and it is also a 3 cross 3 matrix. Okay, so in the next class we will see how we can derive the equations, the transformation equations for the time derivatives of these psi, theta and phi. Okay, so if you have any doubts or any special videos, if you require some special attention to some topic, if you think I should discuss about it more elaborately, please write it down in the comment section. Thank you and see you in the next class.